Welcome back to FMA 0134 Mathematics 3 Chapter 5 Hyperbolic Function. In this video, we're going to go for the most exciting part of our hyperbolic function. That is the derivative and integral of our hyperbolic function. Okay, before we go to the formula or the list of formula or sometimes we can say the cheat sheet of our derivative and integral of a hyperbolic function. So let us to see that is two examples over here. That is how we can get our when we want to find the differentiation of our shine. Okay, so the actually it's quite easy. So we just write that our shine in the term in terms of a exponential. So we just differentiate normally. So differentiate ex actually is still ex back, and differentiate the minus ex, we're going to have a plus minus x, and then the two will never change actually because this is a coefficient. So actually this one is our cos x. Okay, so how when we have our cos x, the same thing. So differentiate 1 over 2 ex minus e minus x actually is sine x. Okay, so now if you see here there is, please don't get confused with our differentiation of our trigonometry function. In our trigonometry function, differentiate sine actually is cosine, and then differentiate cos trigo is become a negative sin. But the thing is, over here the differentiate sine or the cosine, we're not going to get a negative. Okay, so actually this one is a list of derivative and the integral of a hyperbolic function. Okay, so then as usual, that is for the differentiation. For this one is called general formula. Okay, this is the general formula, which the x is replaced at a u, which u is the function of x. Okay, so over here actually u be a differentiable function of x. So that means you're going to use chain rules. Differentiate sine, you're going to get a cosine, and then don't forget, because this is a chain rule, so you need to differentiate the u at the outside multiply. And like just now, differentiate cos if we're getting the sine, and as then we differentiate tangent hyperbolic is a secant square. Okay, it's the same thing. And then for cotangent, we're going to have a negative cosecant, and then differentiate secant, you have a negative secant tangent, and then the last one differentiate cosecant, you're going to get a negative cosecant and cotangent. Okay, and then you see that these three of them have a minus. Okay, so contrarily for our integral, they will be having the facing, because the integral is the antiderivative or the revert of our derivative. So means that when we differentiate sine, you will get a cosine. So means that I integrate cosine, I will get a sine. Okay, and then this one have to a little bit decrease here. Actually, this is a cos u, this is a u. Okay, this is not cos u dx. This actually is a cos u du. So means that if you want to integral except the u and u, you need to use the others method like substitution and so on. Okay, so integral sine, you will get cos. Integral secant, you will get cotangent, and then integral the cosecant, you will get the negative cot, and so on. So these are all the formula of the derivative and integration of hyperbolic function. Okay, and now we still need to recall back is you only have when derivative, you only have three different methods. The first one actually is we have a product rules. Okay, product rules is what I always say is a UV. Then we have a quotient rule, U over V, and then we have our beloved chain rule. So this one is the one just now. We have an FU and so on. Okay, so now what we need to do is when we want to differentiate secant, so what we over here is we look at our secant. Differentiate secant is negative secant u tangent u, but this is 2x, so means that is our u actually is 2x, so means is this one. When we differentiate, okay, we differentiate, so because this didn't put dy dx, but you need to put dy dx. D over dx, dx, this one is negative secant. Okay, actually, sorry, it's a secant u Okay, secant u. So u is 2x, and then we have our tangent u. And don't forget the multiplication of the differentiation of a 2x actually is 2. So I put in front the 2. This is the differentiation. Okay, then we know that is when we want to differentiate sine, we know it's going to get a cosine, and then you copy back first, and then we differentiate. Because I don't want to put at the back, I put our differentiation at the in front. Okay, and then there is no difference for the differentiation of the hyperbolic for the power. So what you need to do, just follow the power differentiation of the power. You push the key in front. 3 cos squared. Okay, 3 minus 1 is 2. Copy back 2x. Differentiate cos actually is sine 2x, and then differentiate what is inside 2x actually is multiplied by 2. So finally we have a 2 cos squared x 2x sine 2x. Okay, maybe some of you do you need to change? Okay, if some of you feel that you want to change, because cos squared 2x can change into the sine 2x, it's up to you if you want to change. If not, then leave it as it is. Okay, now this one, this the example in the class, we will look at during the class time. Okay, so now for the integration, okay, so the integration are the same. Okay, so as normal, okay, integral sine x dx is cos x plus c. Integral cos hyperbolic x dx actually is sine x plus c. This is what you have. So, but now this one is a 4x, so that's why, okay, if you are not familiar with the direct integral, so what we can see that when I want to integral sine 4x dx, so I can let my u equals to 4x, so du equals to 4 dx, or our dx actually is du over 4. So this question is become integral sine u du over 4. So you're going to have your cos u over 4 plus c. Then change back our u become cos 4x over c over 4 plus c. Okay, but for the student who already quite familiar with the normal this kind of a 4x, which is a linear, so what you can do is, when we talking about our derivative, we have a multiplied 4 in front. For the difference, so for the integration, we're going to divide. Okay, so means that I know that is I want to integral sine 4x. The sign here is going to get me cos 4x because it's not going to change, but because this is a 4x, I'm going to divide by 4. Because integral is always is revert of our differentiation. Differentiate means is multiplied 4 if integral is divided by 4, and remember this is only can happen if it is a linear. Okay, then the second one is integral sine squared x. Okay, now this question, okay, I don't know, okay, I don't know how you're going to answer. Okay, actually, if you are quite familiar with your chapter 1 in mathematics 2, you will know that is you can't integrate, you cannot integrate sine squared x dx. Please don't tell me this is a sine 3x over 2 over 3 plus c. Okay, if you really give this one, I really will be hammering you. Okay, this is wrong because when you do differentiation, okay, so whether you want to say that why it is not, okay, so when we take sine squared this one, if we differentiate back, we will get 3 sine squared x cos x n over 3. So are these two same question? No. Okay, so please, okay, so whenever it is not a linear, okay, for our any either is trigonometry or hyperbolic, they are at the same boat. Okay, so means that you need to change this one according to the formula. So what is the formula? So we look at the equation, the formula provided here. We try to change it into a linear. Okay, we try to change it into the linear. So just now we have a sine squared. Okay, when we have a sine squared, we have the first one is this one, second one is the second, this one. There's no more sine squared. Okay, the third one may be this one. Okay, so you have one first choice, second choice, and the third choice. Which formula you want to use? Okay, if you look at this second and third, if you change this sign squared, you will get cos squared. You will go back to the same boat. And if you use the second one, if you choose this sign squared, you're still going to have the cos squared. You are going back to the same boat. So the only choice you have is this one. You take sine squared x equals to cos squared 2x minus 1 divided by 2. So we're going to use that formula. So from the formula, we know that is, okay, the sine squared x, we can change it to become cos 2x minus 1 over 2 dx. This one is by the formula. So we change it, our sine squared to become integral this one. So now you can integrate normally because this one is already linear power. It's normal power of 2. So you will have a sine 2x over 4, because this is 2, then you have a half x plus c, settle. Okay, so this one is the second question. The third one, why I choose this question, I just want to let you know that is, don't ever you see the e, you will think that it must be exponent x. Okay, if you see the power here actually is 2. If e2 actually is a constant, so this question integral e2 cos x dx actually is, e2 is a constant, so you have a e2 sine x plus c, settled. Okay, now these are the example in the we are going to discuss in the class. Okay, now there are another one type of the questions. Okay, this one, okay, actually can be using together using with our call is called what, integration by part. But over here we have another one method. It's called tabular method. Tabular actually is from the terms of table. When you are put it into a table, they call it as a tabular method. Okay, so this tabular method, we look at the first one. Okay, so you remember that is, whenever you have the integration by part, we follow you follow Lopez, right? So now this one is a L, and then we have our polynomial. Okay, so actually this one is only happen for the case you choose your polynomial, because the first case is a one function, either your y1 or y2, can become 0 after differentiating a few times, because you know that is your whenever you have a logarithm, you will never ever have it never happen you going to be disappeared. Only the polynomial can go disappear. So this case is only happen when you choose your u as your polynomial. Okay, so when we have choose u as a polynomial, so how to use this tabular method? In this table, the first one, we put the column as a sign. Okay, the sign. The second one is called when you need to differentiate. Whenever in the column 2 is the differentiate. The third one is integrate. Okay, so the sign over here is always positive, negative, alternating the sign. Okay, so what you want to put in the A1 is whatever you choose as a polynomial, and then the rest of it we put it as an integral. Okay, so let us look at we go back in your chapter 1. So chapter 1 in your max 2. So when you have a 2x sine x, so I choose the 2x, actually is a polynomial. So I put the 2x here. Then the balance is sine x. So I put it in the integrate. The sign is always positive, negative, positive. So this is 2x. Different. Whenever you see the under the differentiate, you differentiate. Differentiate 2x actually is 2. Differentiate 2. Okay. Or we no need to write this way. We also can write the differentiate. The 2 actually is 0 because we are differentiating from the row before, and then we are integrate x is become negative cos, integrating negative cos actually is negative sine. Okay, so remember this one is integrating, this one is differentiating. Okay, Okay, so now after you already have this table, so how you want to present your answer, that is, okay, the magic here is they are not using the diagonal way. Okay, so they are, you start from the sign, this is a positive, so you're going to the positive multiplied 2x multiplied the negative cos x, so you're going to have the, so the first arrow is you're going to have a negative 2x cos x, then the second arrow is you have a negative 1 multiplied by 2 and then multiplied by negative sine x. So you have the, because negative negative is positive, so you have a 2 sine x. And then when you want to combine these two answer, you just use the plus. Okay, it's not multiplier, it's a plus. And then you use the plus c. Okay, don't forget to plus c, because this is an indefinite integral. So now let us look at the case 2, which is our the choices cannot become a 0. Okay, so if you can see that here is a tabular method are not suitable to use for the L. Okay, so it's only happen for the PET. So L cannot. So if you see the L, so you need to back to the first method. So you need to go for the integration by part. Okay, so for the LOPET, so sorry, for the second choice, second case is the ET. For the ET, it doesn't matter which one you want to choose. You want to choose the exponent also can. You want to choose the trigonometry also can. So just choose either one. Okay, because the exponential and the trigonometry never ever can be differentiate. I mean, it cannot become a 0. Okay, that means is you can't finish differentiating it. So what is going to happen is you need to check. Okay, for this one you need to check. Okay, so when you do the it's still the same. The first one is alternating the sign. The second one is keep on differentiating. The third one is you keep on integrating. So how you want when to stop? Okay, normally in the case in the step 3, okay, normally in the step 3 you already need to stop because basically you already back to your questions. Okay, so now we look at one of the example, ex sine x. So because the exponent and the sign both cannot be finished of differentiating, so we just put the ex as a differentiation and then integrate, we put our sine x. So this one, the first one differentiate, you have an x, and then this one you will get a cos x. Okay, then you keep another one time ex sine x, and you can see that is in your row 3 you already back to the same element as your row 1. The only difference will be the sign. Okay, the sign minus this one is positive, so doesn't matter. So what you need to do is same thing, row 1 you copy from positive multiply ex, then multiplied by negative cos x. Okay, so you have a negative ex cos x. Then the second row, you have a negative 1 multiply ex multiplied negative sine x. So you will have a negative negative this one. And for the third row is very special. Please be alert that is for the third row is this one you are going diagonally. Okay, you are going for horizontally. So you have a 1 multiply ex multiply sine x, but you, if you see here, they already auto adding the integral dx. So for the row 3, which when you go for horizontally, you need to put integral dx. Okay, so then we also the same thing is for 3 of them, we just combine them by integral. And why this time there is no c? Because you have an integral at the back. Okay, but normally if you see that is they have a little bit, actually these two are the same. Okay, these two are the same. If you still recall, okay, if you recall how you do for your integration by part, they are the same category. They already fall into the same case. That is, you have a left hand side and the right hand side have the same questions. Okay, or the same question they ask you, the same problem. So from the right hand side, you shifted to the left hand side. So you have a 2. So, and then after that, you shift the 2 over here, then don't forget to put a plus C. Okay, so don't forget to put a plus C over here, because after you shift to the right hand side, there's no more integral, so you need to put plus C. Or over here, if you see that you want to put a plus C, also doesn't matter, so it's up to you. Okay, so now let us look at the first case. So for the first case, okay, now we discuss back, okay, we also following the row path, okay, because our hyperbolic function having the same shoe with our trigonometry, so either for the trigonometry or the hyperbolic, they are the same level, okay, they are same level, so either if you have a combination of a trigonometry of a hyperbolic, there will be either one you can choose, okay, but it will be in the same category. And remember, if you look at for your chapter 4, our logarithm is together with our inverse trigonometry. Okay, so since this one is following hyperbolic at the last one, so x actually is our polynomial. So what we need to do is, so we build the table, okay, so this the first one actually is sine. Doesn't matter, we just put positive, negative, positive, okay, regardless how many, we just put first. And then the second one actually is differentiation. The third column actually is integration. Okay, so as we know that is following the log path, the one you need to choose as a u is you must choose the polynomial. So over here is x. So the one balance actually is sine x. So differentiate x actually is 1. Differentiate 1 is 0. So then different integral sine actually is cosine. Remember there is no negative. Integral cosine actually is sine x. Okay, now how we want to present our answer is follow. Okay, so how we want to present our answer? So we follow the first one, okay, the yellow line. And then the second one we label is as a green. Okay, so since this one is 0, there's no diagonal. Okay, sorry, there's don't have a horizontal. So how you going to present your answer? Actually, this one is equals, okay, equal to what? The yellow line, first thing is a positive. So positive, okay, what happened to my pen? Okay, my pen, okay, so it equals to positive, so x cos x, okay, then minus, because this one is minus sine x, and then put plus c, settle. Okay, so actually this question is the same thing is as integration by part. Okay, integration by part is you, for this one, if this is an integration by part, so you need to let your u actually is x. So sorry, you need to let u equals to x, then you have a du equals to dx. So integral dv equals to integral sine x dx. So v actually is cos x plus c. And remember, the formula is uv integral v du. So uv is x cos x minus integral this one. V is this one, cos. Du actually is dx. So we have an x cos x minus sine x plus c. Same. Okay, so that means actually tabular method for certain question, it is easier compared to integration by part. Okay, you have a less, actually it's not say easier, actually you have a less thing to write. Okay, so then we look at, okay, so if this one, okay, so how about when you have an x square? Okay, so the same thing, what you need to do is, the first one is sine, positive, negative, positive. Then the second one is the differentiating. The third one is integrating. As usual, since this is a polynomial, we choose this is x squared, this is a sine x. So differentiate x squared is 2x. Then differentiate 2x actually is, is 2. And then means it's still not 0. Differentiate one more time. So we have a minus here, so it's 0. Sine, cos, sine, cos. Okay, so follow the arrow. Your answer will become x squared cos x and then multiply. So minus 2x sine x, and then the last one is plus 2 cos x plus c. So for the integration by part, we will discuss it during the class. Okay, so how about when you have something which is not polynomial? Okay, so same thing, sign. This one is a positive, negative, positive, and then you choose d over dx. This one is integral. So it doesn't matter which one you want to choose. So I just put my e3x here and then my cos 2x here. Okay. So differentiate exponent is 3x. If you differentiate again is 9e3x. And different integrate cos actually is sine 2x. And don't forget over 2. Then integrate this one again actually is cos 2x over 4. Okay, now actually if you look at it, e3x is same as e3x, cos 2x is same as cos 2x, only the difference will be the coefficient, so doesn't matter. So now over here the row 3 we already can stop. So remember how we going to get the present the answer. The first one is this one, so answer is e3x sine 2x over 2. Okay, this is a minus 3e3x sine 2x over 2. Okay, now because the last one we are going to be horizontally, remember you need to put integral 9 over 4 e3x cos 2x dx, and c straight away we put a plus c in case we forgot later. And this one actually is same as your question. So we shifted to the left hand side. So we have a 1 minus 9 over 4 of our question. Then is equals to our right hand side. This one. Okay, and plus c. So then this one actually is become negative 5 over 4. So how you want to get the final answer? You just revert back. Is actually is negative 4 over 5 of this one plus c. Okay, so this is the, if you want to integrate the which is the combination for the hyperbolic and the exponential. Okay, then we have others we're going to look at during our class. Okay, thank you.